Alright, welcome everybody to lesson 5A, Multiplying Binomials. Now, we are starting chapter 5, and like I said, most of chapter 5 will be focused on the algebra behind how to convert between the three forms. So, first off, we notice that this is our vertex form, this is our factored form, and this is our standard form. So today's focus is being able to go from one of these two forms to the standard form. Now, what's the main difference? What's the main thing you notice that's different about the vertex and factored form from the standard form? It is the lack of brackets. Okay, so our focus today will be multiplying binomials, which is telling us to expanding binomials. And when we hear the word expanding, we are essentially just getting rid of brackets. Okay, getting rid of brackets. It does not mean what Peter over here thinks it means. Expand. Ha, hopefully I got a cheap laugh out of you. Anyway, scrolling down, expand the following. So how does this relate to quadratic functions or parabolas? Well, you'll see down the road. But actually, you know what? In fact, if you look at that right now, picture this in your head. Picture this as an x as opposed to an n. Then what you might be picturing is something like that. Okay, it's opening up. You can pretend that this says y equals, and pretend there's an a value there, or the a value is 1. Then these two will tell you your x-intercepts. That means -3. So let's see, x and y. So -3 would be one of them. And then if you solve that, 3n plus 2, you should get -1/2. Okay, and that will give you your other x-intercept. But that's not the focus of this chapter. The focus is now, how do I get this out of the brackets to get it into standard form? And that's what we'll be doing today. Now there is an acronym that helps some students, not so much others, but I'm going to show you it anyway, and that is FOIL. FOIL. Okay. What does this acronym stand for? First, out, in, last. Okay, so first out. So, see this term right here? I'm not a big fan of this because it can get confusing, but you might see this in the textbook. I don't remember if this was in the textbook or not, but just to show you, first in means we're going to take the first term, okay, of this first bracket and multiply it with the first term of the second bracket. So here we would have, I'm going to color code this to make it easier. So 3n times n. Well, there's no coefficient in front of that n, is there? We can assume there's a 1. So 3 times 1 is 3. And then n times n is n squared. Now thinking back to last lesson when we multiply, what happens when we multiply the same bases? We add the exponents, and the exponent here is a 1, exponent here is a 1, 1 plus 1 is 2. So 3n squared. Okay. Now let's change this to blue. Now we're still sticking with that first term. Okay. So first out, in last, so first out. Okay, now we're going to multiply again 3n with the 3 to get plus. Well, 3 times 3 is 9. 3 times 3 is 9. And 9 what? 9n. So 3n times 3 is 9n. Now we take a look at let's choose green. So now we take a look at the inside term. So 2 times n is plus 2n. And then The next term we will use, let's see if yellow will show up. 2 times 3 is plus 6. Notice how there's no n attached. Okay, and then from here we can collect like terms. Now, collecting like terms, so I'm going to use, I don't know, say purple. So 3n squared. Is there an n squared anywhere else? No, there isn't. 3n squared. 9n plus 2n. So these two added together, because they're both n's, will give you plus 11n. And then the 6 on its own plus 6. Okay, so this, it would be in standard form. This is the expanded form of the original. Okay. I'll do a couple more examples. And in fact, if you want to check your answer here, you could open up Desmos, type this in, okay, and type this in, and you will get the exact same graph. Okay, so let's try this one without using the various colors. So again, first out, so the, I guess, outside term, n times 2n would be 2n squared. 2 times 1, because there's a 1 there. N times n is n squared. And then n times negative 2, negative 2n. And then the second term, or the inside term last. So 1 times 2n is negative 2n. Now pay attention to the sign that comes before it. Negative 1 times 2. And then last but not least, negative 1 times negative 2, which will be plus 2. Okay? So again, we can collect like terms. So this will give us 2n squared, negative 2n minus 2n is negative 4n plus 2. We're done. Okay? We'll do a couple more. Let's do number, I don't know, let's do number 6. So again, the first term times the first term of the second one, 3p times p is equal to 3p squared. Okay, and then 3p times negative 1 will give me, oh sorry, I forgot the square there. 3p times p is 3p squared. 3p times negative 1 is negative 3p. And then negative 3 times p is negative 3p again. And then last but not least, negative 3 times negative 1 is plus 3. Okay, so this will give us 3p squared. And then, like terms, negative 3p minus 3p is negative 6p. And then plus 3. Okay. Now let's scroll this down a little bit and let's pick some of the harder ones. Okay, expand the following. So now these ones look a little bit trickier, but the steps are similar. So let's take a look at this first one. Now I notice how there's a coefficient in front now. There's a 3. Now you can picture this as your a value, although we're not graphing here, but later on this will be our a value. Now if I told you to expand the following, what would you do? Well, to expand the following, I would take a look at that and ignore the 3. Okay, I would ignore the 3. So for example, this would just be a 3. Okay, so that's the 3. And then I would focus on just simply that. Okay, so by focusing on that, if I just, let me just change the color here. I'm just focusing on what's in the bracket. So I'm going to, in fact, I'm going to trace this with the red. So you can see I'm just focusing on what's in the bracket. So what do I have here? X times x is x squared. X times 6 is plus 6x. Negative 5 times x is negative 5x. And then negative 5 times 6 is negative 30. Okay. And then, let's go back to my purple. equals 3. Now let's simplify that. Let's go back to my red. So what would I have in here? I would have x squared. So plus 6x minus 5x will give us 6 minus 5, so plus x, or plus 1x. You don't necessarily have to include the 1, but I'm going to anyway. Plus 1x minus 30. Okay? Now your last step is then to expand that 3 into every term, which means this 3 is then going to be multiplied with that, by that, and that. Okay? So then what would we get here? We would get equals 3x squared plus 3x, and then 3 times negative 30 is negative 9. And here you have it. You're done. Now I'm going to do one more, then I'll leave you guys alone. And that's one of these ones. There's 2 at the bottom, and you will have a couple of these in the homework questions, but don't be intimidated by them. In fact, no, let me do this one too. I'll do this one very quickly. So we do the same thing, the same steps as we did above. I'm going to ignore the m and only focus on this. Okay, so then what would I get? M times m is m squared. M times negative 3m is negative 3. Now, careful. Notice how it's m times m is m squared. M times n, do I know what that is? No, it's just whatever m times n is. And now the inside terms. So negative 2n times m, negative 2n times m, and then the last one is plus 2 times 3 is 6, and then n times n is n squared. Okay? And then, again, let me just simplify what's in the bracket first. So I'm going to copy that down, m squared, and then negative 3mn, negative 2nm. Is mn and nm the same thing? Tomato, tomato. 2 times 3 is 6. Is 3 times 2 also 6? It sure is. So the order here doesn't matter. In other words, m times n is the same thing as n times m. Which means these are indeed like terms, which means I can group them. So negative 3 minus 2 is negative 5 mn plus 6n squared. Now your last step is to multiply the m with everything that's in there. Okay? Now thinking back to last lesson in regards to exponent rules, this is the exponent of 1, right? Now if we're multiplying these two, m times m, the base stays the same. Now what do we do with the exponents again? We add them. So 1 plus 2 is 3. So that's the first term taken care of. Now if I multiply m with the second term, I would get negative 5. Now this is just as m with the exponent 1, right? So m times m would give me m squared. And did I do anything with the n? I did not, and that's done. Last term, m times 6n squared. Well, there's no m here, so it's just simply 6m n squared. Done. Okay? Alright, let's tackle one of these hard ones. Now, these hard ones aren't necessarily hard. It's just a matter of being able to break it down into simpler steps. So, in fact, I'm going to leave these two. Okay? I'm going to let you do it on your own. I don't want this video to be too long. But the idea is to just focus on x plus 4 times x plus 6. You'll get some answer for that. X minus 1 times x plus 1. You get some expression for that. Once you have two long expressions, collect all the like terms, and you'll get one final answer. Okay? Now, there are some special products. Okay? And these 9 questions are strategically chosen so that you can maybe see a pattern. Okay? Now, I'm not a big fan of memorizing. Okay? It is helpful down the road to know these, but if you simply know everything prior to this page, how to expand, you're okay. So why am I saying that? Well, let's take a look at 1 and 2 for a second. So if I were to expand this, x times x is x squared, x times 3 is plus 3x, 3x plus 3x, or sorry, 3 times x is plus 3x, 3 times 3 is plus 9. Okay? Now let's simplify this. So x squared, and then 3x plus 3x is plus 6x plus 9. Okay. Now, I want to do one more example. So 1, and I want to do number 7 as well, because there obviously is a pattern. Now if I multiply these two, 3x times 3x will give me 9x squared. 3x times 5 is plus 15x. 5 times 3x is plus 15x. And then last but not least, 5 times 5 is plus 25. Yeah, so now that's 9x squared plus 15x plus 15x is plus 30x plus 25. Now these are special in the sense that there is a quick way of going from here to here, here to here. Okay? And if you notice something else, what do you notice about what's in the bracket in both of these? They're the same. X plus 3 times x plus 3. 3x plus 5 times 3x plus 5. Now, do you see anything? A pattern. There is indeed a pattern. Okay? Because there's no coincidence that 3 times 3 is 9. Okay? And that 6x is simply 3 plus 3. How about down here? 5 times 5 is 25. But then how did we get 30? Well, the 9 makes sense because 3 times 3. Okay? But how did we get 30? Well, let's take a look at this. What's the square root of 9? 3. What's the square root of 25? 5. What's 3 times 5? 15. 15 times 2? 30. What? Mr. Tram, that made no sense. Well, if that confused you, again, like I said, you don't have to worry about that because you can simply use your skill of being able to expand binomials to get to this step anyway. It's just a shortcut. So this is what we call a perfect square, and I'm going to write that down here. Oops. Let's go with red. Okay. Perfect squares. Okay, so if I had, let's say, a plus b times a plus b, notice how they're the exact same thing. Well, what do I get? Well, my result is, if I look using this as an example, 3x times 3x is 9x squared, right? In our case, our a is our 3x. So our first number would be ax squared. And let's skip the middle for a second. We also know that the last number, 5 times 5, is just whatever b squared is. Now, it's that middle number that we're not too sure of. But we realize that isn't it just the square root of our last term, which is 5, the square root of our first term, which is 3x. Okay? And if we multiply these two, 3x times 5, that's 15x, right? And then we just had to double it. So what's the middle term then? It's simply just 2. Okay? 2 times whatever the square root of a is and the square root of b is. So how is this helpful? Well, now every perfect square, if you are comfortable with memorizing an extra little step here, you can quickly expand it in one shot without having to include this middle step, without including this middle step. Okay, so for example, in this case, is this a perfect square? 2x plus 1, 2x plus 1, they're both the same, they are. So I can quickly just go, okay, well it's a squared, so 2x times 2x is 4x squared. Okay, and then the last term is 1 times 1, that's just plus 1. And I know the middle term is plus 2 times whatever A and B are, well, I'm just going to write A plus B, A plus B, okay? So it's just going to be A squared. Let me just, make it easier for you. Okay, so you can see that the first term is A times A squared. Last term is B times B, B squared. A times A squared. B times B, 1 times 1, 1 squared. And then the middle term is just 2 times AB. So we can quickly see just 2 times whatever A times B is. Well, 2x times 1 is 2x. So 2 of those 2x's. And you're essentially done. And I guess you just expand that out. So that would give you 4x, but that's an easy extra step. Okay? Now, the other one is called the difference of squares, and I know this video is running a little long. Now, of course, the beauty of the online is you can stop and pause whenever you'd like. Okay? Or forward, or skip, yada yada. Now, if I look at these two, are they the exact same? They are not. In fact, they are similar. The only difference is that the signs are different. Okay, let's see what happens when we expand this guy. Okay, so if I multiply the first term with the first term, I get x squared. If I so x times x is x squared. If I multiply the first term with the last term, I get plus 3x. If I multiply this with that, 3 times x, so I'm just expanding it right now, that will give me minus 3x. And then last but not least, negative 3 times positive 3 gives me negative 9. Okay, now let's simplify this. What do we get? Well, the two middle terms, plus 3x minus 3x is 0x, right? Is there any point in me putting 0x here? No. So then these two cancel out. So I'm just left with minus 9. Okay, let's take a look at this one. X times 2x is 4x squared. And 2x times 2x is 4x squared. 2x times 1 is plus 2x. Negative 1 times 2x is negative 2x. And then negative 1 times positive 1 is negative 1. Oh, again, plus 2x minus 2x. Doesn't that cancel? Sure does. And then I'm just left with 4x squared minus 1. Well, how did I get x squared? The first term, x times x. How did I get 9? 3 times 3. How did I get 4x squared? 2x times 2x. How did I get 1? 1 times 1. So this is what we call a difference of squares. Okay? So, how does this work? Well, it's not perfect. It's close. So we still have AB and we still have AB. But they are not the exact same. The only difference is that the sign changes. Okay? Now, if I want to expand that and I notice that A are the same in both, B are the same in both, the sign changes, all I need to do is, what's A times A? This just equals A squared minus, because it's called difference, of squares. And these are both squares. You are done. So in this case, I would have, for example, here's a difference of squares, number 9. No, I'm going to do this one right here. No, I'll do this one. This one just equals 2. Ignoring this 2 in the front for now, I'm just going to copy down that 2. If I want to expand that, if I just focus on that, ignoring the 2, well, yeah, are they a difference of squares? 2x, 2x, 7, 7. Yep, only difference is that one's a positive, one's a negative. I know that this is a difference of squares, so I know that it's just going to be 2x times 2x, which is 4x squared. 7 times 7 is 49. minus in between, I'm done. And then I could just multiply the 2 in. Okay? This will give me 8x squared, and then 2 times 49 is minus 98. And I am done. Okay? Any questions, as always, please post under the math questions forum, and I'll answer them with a quick video. Anyways, have fun.